Hello, 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 and welcome back, Chemists, to a little practice review day on Charles Law. Today, you're meant to check your answers that you were working on yesterday and keep working through the booklet and that practice sheet I gave you. Then I'm also posting another practice sheet with a key if you just want to keep doing these, because, as we said yesterday, practice makes perfect, and it certainly does. So today we're just going to go through two classic examples of this problem. I posted a bunch of keys for stuff online, and this is your day to really get used to doing Charles Law problems. So to spend the time practicing up so you're like all set for when we ask you some questions later on. Tomorrow, you'll be getting some questions on Charles and Boyle's Law, so make sure you're all suited for that. Anyways, without further ado, chemists, here we go. This question is asking us, what is the new volume if 200 milliliters of gas at 20 degrees Celsius is warmed to 88 degrees Celsius at constant pressure? So we're relating volume and temperature, and pressure isn't changing, so that is what a Charles Law question is. We're looking at the relationship between volume and temperature. Before we get too far here, I will draw your attention to this formula. This is the formula that we end up using to relate Charles' law between volume and temperature, saying here that like your volume at a given temperature is proportional to your volume at another temperature. So we're able to find out how volume changes if you change temperature, or what temperature change caused a change in volume. So I'd like to invite you to try mapping this out and see how far you get, and we're going to solve it together in a moment. But if you want to pause it and give it a go beforehand, that's extra awesome. Remember what school you go to. You go to Calvin, and that's an important hint for this type of question. So in 5 seconds, we'll go a bit further, but 5, 4, 3, 2, 1, and here are our variables. V1, the first volume, 200 milliliters, that's given to us. The first temperature, it gives us is 20 degrees Celsius, but remember, these have to be in Kelvin. Repeat that after me, chemists. This has to be in Kelvin. So we're going to convert that by adding 273. You should have practiced that quite a bit yesterday in your booklet. If you haven't yet, go to your booklet. There's a whole page and a whole page of the key about doing that conversion. Then our volume 2, that's what we're looking for. And then 88 degrees Celsius is our final temperature. We have to change that to Kelvin too, so plus 273, 361 Kelvin. Okay, with that in mind, if you haven't gone on yet, try to plug these in and get to a final solve, and then compare your answer to me. Because the more you practice typing these into your calculator and working with the variables, the easier they become. So we'll get back to you in about 5 seconds. So 5, 4, 3, 2, and so this is how we set it up. 200 over 293, V1 over T1 equals V2, which is what we're looking for, over T2, which is 361. Then we're going to do some algebra. Move that 361 up, just multiply by it on both sides. Now at this point, I invite you all to take out your calculators, type this in, and make sure you're able to do this final little part of the calculation. So I'm going to type it in alongside you right now. Pause the video if you don't want a spoiler in just one moment. Alright, spoiler warning was given, so this is going to cancel our units of Kelvin and give us an answer in milliliters. And we get 246 milliliters. So if you're able to get that from looking at this question, you're in awesome shape. If you need some extra practice, don't worry, that's what the next example is for, and your practice sheets. But that's a classic example of how one of these questions will map out and how you'll work through it. The next example has a little twist though, so I'm going to throw you a little challenge right now. Let's see how it goes. What was the starting temperature in Celsius if 333 milliliters of gas was equal to 222 milliliters at 260 Kelvin? 222 just makes me think of pizza now. Uh, but yeah, so again, formula, same. Now I invite you to map out our V1 and T1 and V2 and T2 and figure out how to set up these variables. And if you want, go ahead and go all the way to solve it, and we'll catch back up with you in a few moments here. So pause it for a moment here and try to map this out, and potentially solve, but if you want to check after you mapped out, that's cool too. So 5, 4, 3, 2, 1, and Alright, so we got V1 is 333 milliliters, that's given. T1, that's what we're looking for. And V2, 222 milliliters. And then our last temperature is given to us in Kelvin already, so we don't need to do anything with converting it. So let's plug those in. Now this algebra is a little bit more difficult than the last one because there's a couple steps, so I'm just going to show you what we're really doing here. We're going to multiply by 260 to this side to get rid of it on the bottom, and multiply by T1 on this side to get rid of it on the bottom. Then we get left with this whole deal. Then the final step will look like this as your setup. If you're able to work through that in algebra, it's fine, however you're used to it. I know a lot of you are practiced up in solving equations and you may have your own tricks, so like that's cool. But in general, that was like the trajectory we went to isolate T1, because that's what we're looking for. And that's about as bad as this math is going to get for these type of problems. So anyways, type that into your calculator and see what you come up with, and then see what final answer you come up with. Emphasis on final and answer. So we're typing that in, spoiler ahead, and units cancel, of course. We end up with 390 Kelvin. That's it, we're done, right? Nope. If you already went and noticed something we have to do to that, that's awesome. But this one has a little bit of an extra step here because it's asking for our starting temperature in Celsius. It's asking for our temperature in Celsius. We can't give our final answer as Kelvin. So we're going to say T1 equals 390 Kelvin minus 273, just the opposite of what we do in the other direction. And we get 117 degrees Celsius, and that is our final answer. So chemists, with that in mind, keep practicing. Feel free to email me with any questions you may have at mrbsciencemb@gmail.com, and have yourselves a lovely day. Bye-bye.